All right. Well, I think maybe this will just be a little lower pressure and maybe shorter. So yeah, let's get started here. I'm starting a new research discussion series here on incorporating other kinds of features into BERT. There's a lot of research and interest going on right now with like combining text and visual features, but here what we're really looking at is simpler features like continuous features or categorical features is kind of the main one that I'm highlighting. So a categorical feature, there's this example data set we're going to be looking at that I think has a good example of the mix that we're talking about. So this is a data set on Kaggle that's called the Women's E-commerce Clothing Reviews data set. It was kind of scraped from some retailer's website. There's not actually like a competition around it, but the data set's available. It's got 23,000 reviews. So it's got review text in it, which we can feed into BERT, but it's got all this other helpful information as well, like the age of the reviewer and the division or department name that the clothing item came from. And then the goal is to predict whether or not the reviewer recommended the piece of clothing. So part of what's particularly tricky about categorical features, like the department name, let's say, as an example. Let's see, I'm going to zoom in a bit. Didn't realize it was so small. Sorry, guys. Yeah, so what's special about categorical features is that you can, so there's like a unique set of possible values that this feature can have, right? Different departments. And you could simply represent those different departments by, a unique ID or integer for each different one. The problem with that, though, is that unlike numerical features or continuous valued features, the difference between the values is meaningless. So, subtracting, I don't know, like, what are the different, let's see need an example here, division name and department name. Yeah, so subtract, if like tops is 1 and dresses is 2, then dresses minus tops, like that doesn't, that has no meaning. So that's a little problem. That's a little problematic when you're trying to incorporate that kind of feature into something like a neural network where the difference between values is really meaningful. So we're going to look at strategies for incorporating categorical features as well as like continuous valued and numerical features into BERT. All right, so Nick found this toolkit out on GitHub that's it looks like a pretty great resource for us because it basically is directed, very specifically at this problem that we're trying to tackle. It's from this company called Georgian.io. It's a little tough to figure out what they do. They seem like maybe kind of a consulting group. They've got investors and machine learning researchers. So anyway, they've put together this toolkit. We'll look at that in a minute. Actually, we're going to look at it now. Yeah, they're in Toronto. Yeah, so I wanted to look at the toolkit. I was going to look at the illustration they've got in there, some of the combination methods, right? Look at some benchmarks. All right, cool. Let's see. Here we are. Scroll up. All right, multimodal toolkit. So the word multimodal refers to kind of that problem of combining different data types. If you do like a literature search right now on multimodal, what you'll find mostly is like combining text with vision or audio, but it does apply to incorporating categorical features as well. So that's what that word's all about, multimodal. All right. Yeah, so this is a good kind of like, oops, zoom out. Good overview of what their toolkit does. So it lets you take in a data set like this clothing review one with all these different kinds of features, and you feed them all in. The text goes through a transformer, and then there's this combining module. That's kind of the key. That's the key contribution of this toolkit, and they provide different ways to combine the output of BERT with these other features, and then they send it through like a either like a MLP or a linear classifier to do your final prediction. So yeah, they've got a few data sets included, which is really cool that they found, I guess. So the women's clothing is the one we'll be looking at today. There's also this like Airbnb price prediction one, and this pet adoption prediction. I haven't looked at that one yet, but it's cool that there's some. This was the first thing we did was like Nick and I tried to find data sets that we could use that would that we could kind of demonstrate techniques on, and that was tricky. So it was great to find this toolkit that also points to some example data that we can play with. Okay, so the combination features, I feel like that's a little too zoomed in. There we go. All right. Don't think I want to read through all of these. There's probably like 10 of them. But briefly, I think the kind of the first obvious method that comes to mind for me that I feel like you've got to try as a baseline is that you could just take let's see, just use the text. Okay, text only means like just literally just the text, so that's not what we want. Maybe they don't have that in here. Yeah, I guess it's not really so much a method in the toolkit as like something you can try, but you can try just like taking those features, converting them to text in some way, right? Like you could say, this item is from the dresses department, and you could prepend that to the review, and then you can give that to BERT. So the whole thing just becomes this like, the whole input just becomes, a string, all text. So that's one method. And it does actually seem to do fairly well in their experiments. You can try, just concatenating on the output of the transformer, just appending those feature values, I assume, to the end of the probably the CLS embedding from BERT. And then there's these more clever techniques. Which I haven't read through all of them, so I don't think I can like really speak to them. There are a couple here down at the end that seem, from their benchmarks, seem fairly promising. One looks to me like relatively straightforward and kind of the one that I think I want to look at first. So basically, it's like a weighted sum of the different features. So I'm calling that like the linear combiner. And then there's this much more complicated model that came out of a research paper integrating multimodal information in large pre-trained transformers. And they use some gating functions, kind of like an LSTM. Let's see, where were we at? We're over here. So that would be a more complex one to check out, but it seems to also do fairly well. So let's see. Yeah, this is their benchmarks on the women's clothing data set. I guess. So yeah, they mention in here that Unimodal. Let's see if we can find where they explain that in here. Right. So in practice, taking the categorical and numerical features as they are and just tokenizing them and just concatenating them to the text columns as extra text sentences is a strong baseline. Okay. In the experiments below, this baseline corresponds to combined featured method being unimodal. All right, so that's fine. I think now that I'm reading that, I think I understand the distinction. I was kind of confused, like what's the difference between text only and unimodal? But we saw above in the combiner that text only means like just discard all that extra information and use just the text feature. So unimodal is more like convert those features to strings and append them to the text. So it looks like that's actually getting the best result here. So that's kind of funny. So they've got all these other like clever techniques, and just converting it to strings seems to work best. Let's see. Yeah, so the next two strongest are these bottom ones, what I'm calling the linear combiner here, and then this one that involves some gating. So I think those are the two that we might look at. They did have on these other data sets. Let's see. Yeah, here's this one. This pricing prediction is a regression problem, so they're looking for a minimum error. So a smaller value here is better. And it looks like for this one, the unimodal strategy was not very strong, but the concat one was. Interesting. Okay, let's see. What did I want to look at next here? Yeah, so that's kind of an overview of the toolkit. We looked at some of the methods. It does include an example notebook, which is cool. But it only shows you how to train on the clothing review data set. It doesn't show you the test, which is a kind of a funny omission. But yeah, it is fairly, because they turned it into a toolkit, it is fairly like parameter driven and argument driven. So it feels a little convoluted, not very illustrative. So the notebook is really more just showing you like how to use their parameters and their interface. But it's a decent notebook. And then they've got a blog post as well. And actually they used our illustration or Nick's illustration, I should say, of the glue benchmarks. But their blog post is mainly about, it's kind of a literature review, and they mainly are looking at what's out there right now, which is like combining visual and audio features with text, which is, not really what their toolkit's about or what we're interested in right now. So blog post may be a little less useful. All right. So yeah, we looked at the fields for the data set a little bit. There's a great notebook on Kaggle that kind of does like a dive into the features. So I'm used to dealing with been working so much with like vision data a while back, and then more recently lots of text data. And in both those domains, it's always like everything gets turned into vectors, right? So everything's like has a vector representation. But when you're dealing with these more traditional data sets, let's say with like numerical features, categorical features, then there's a lot more kind of like statistical analysis that you can do to gain insight into the data set. So there's a notebook associated with this clothing review data set that does some great analysis. I pulled out some of the stuff that I thought was the most interesting. So, right, so the label is this column, whether or not they recommend it. There's also this rating column, but those are separate. We'll see, yeah, that's the first bullet point here. So I was a little confused at first. It's like, is the rating kind of the same as the recommendation? But they're not quite the same. So there are, let's see, yeah, so kind of let's call that orange is not recommended and blue is recommended. So there are a few, looks like there's maybe even like, one 2-star review where they did actually recommend the product. And there's some where it's a 3-star review, but they still recommend it. And then there's some where it's a 4-star review, but they don't recommend it. And then can't tell if there's any at 5 stars. But so it's not a perfect predictor. The rating alone is not a perfect predictor of whether or not they recommended it in the end. But it does look very strong. It seems like if you just did a threshold on the rating that would get you most that would get you the correct answer on most of these. So that'll probably be a baseline that we have to kind of compare against to make sure that whatever we're doing is a stronger predictor than just thresholding on the rating. Let's see. Yeah, another important factor is that the data set's highly skewed towards positive recommendations. So 85% of the people did recommend their product, whatever product they were reviewing. So again, it's like if you just predicted yes, they did recommend it all the time, then you'd be 85% right. So we gotta pay attention to that and keep that in mind. Yep, that's the notebook we're looking at now. Distribution. Oh yeah, I thought this was really interesting. So they counted up the number of words in the review and found that the positive reviews, the ones that did recommend the product, seem to be pretty consistently longer than the ones that don't recommend it. So it's another fairly strong feature, I think, here. They use this library I'm not familiar with called TextBlob. It's got kind of a quick sentiment analysis feature in it. So they apply that to the data set and plot the distribution of polarity, which is just the sentiment, whether it's positive or negative. And at least using the sentiment analysis tool in TextBlob, it's a good feature clearly, but not an obvious indicator. It seems like most of them are positive to some degree, and while the recommended ones have kind of a higher mean, there's still like a ton of overlap between these two classes. So that alone doesn't seem to be that strong of a feature, which may have some implications, I think, for BERT. If you're just using the text features, then this may suggest that might not do as well as you'd hope. Okay, let's see. So back up to our discussion groups and notes. Yeah, so those are the things that the insights that I thought were most interesting, but they do kind of like, their notebook goes through like every feature and does some different analysis on them. So pretty interesting. So to start with, kind of what I wanted to try was applying some of these techniques to that data set to do some of our own experiments and have kind of our own example code that we can share. I want to start with just some easy baselines that we can use to see like how well we're doing. So we mentioned like if we just always predict one, meaning like if we always predict that it's recommended, then we can get something like 85% accuracy. And then if we just predict based on the rating and say if it's greater than 3, then they did recommend it. If it's 3 or less, then they didn't. You can see how strong that is. It seems like that should be pretty high. And if that is really high, then I might consider like taking that feature out just to make the task a little more interesting and differentiate the different methods better. One that, so kind of another obvious approach that you could take to combining these features is you could use BERT kind of independently to make its own prediction about the text data. And then you could take that prediction score and then combine it with not combine it, let's say, take that prediction score along with all the other features and then feed it into a decision tree classifier. So gradient boosted, XGBoost, gradient boosted decision trees seems to be the most popular one for that. So whenever you're dealing with a combination of categorical and numerical features, decision trees are kind of the go-to. So the Multimodal Toolkit does not include that, to my knowledge. I'll double check that, but I think that would be another interesting baseline to have here. A little more difficult to implement than these other two, but I'd be interested to try it. And then, yeah, and then a couple of things that would be easy for us to implement. One would be just running BERT against the review text only, which I guess is their text only mode, but I think we would do it with our own code. And then again, like do that, what I guess they call the unimodal approach, where we just convert all those features into strings and add them into the text. Yeah, so thought I'd start with those. And then they've got, so since their code's up on GitHub, so I wanted to see their documentation isn't that great on how they actually implement these different strategies. So let's see, they do have some nice docs, which is cool. So here's the docs for the toolkit. Same kind of descriptions of the methods that we saw on the project homepage. But then they do have the equations, which I didn't find super helpful. So the last one here, let's see. You've got, maybe I can make more sense of this now while we're looking at it. But let's see, X is output text features from the transformer, okay. And then C is the categorical features. So this I didn't quite follow. They've got like a weight matrix for the categorical features, and that's not dot product. That means something else. Do you know what that means, Nick? Is it like point-wise multiplication or something like that?
No, I'm not sure.
Yeah.
Does it say just above?
In here? Or, yeah. So kind of what I would expect to find there is like you take the categorical feature, you turn it into if you're doing this like as an equation, then you do it like word to vec. You have like C becomes the one hot vector, and the weight matrix is really just a set of embeddings for the different possible categories. And so really what this would do is just kind of select the embedding corresponding to your particular category. So if it's dresses, then there's an embedding for the dresses category, and what was the other one? Tops. There's an embedding for the tops category. But I don't know how you get that out of this. If they're doing, let's see, WC, I guess it's not, I thought this was like multiplying the weight matrix by its transpose. But that's not what's happening. It's C prime. So, okay. Well, anyway, we'll keep looking at that. The code, here's the code. It's a lot of like, it's hard to weed through, partly because there's not a lot of comments, but then also because it's just like a ton of these, if blocks. So depending on the different combination method, you've got different code that you're going through. So kind of what I wanted to try here is like take out, basically like re-implement what they've got here, but just strip it down to like just what we're interested in, and add some comments and clarify what's actually going on. So it's like for the forward block, there's probably some setup at the beginning, but then really it's like, let's see, where did it go? There we are. It's like, this is the only code I want. I want to look at just that code for the forward. So I think that it'll become a lot simpler when we when we strip out just the relevant code for the strategy that we want to look at. Yeah. So step one, kind of implement some baseline classifiers that both serve as baselines, as well as like, you know, these last three are like, well, these are valid things that you could try, really, that would combine the features in some way. I suppose not this one, but the other two. Yeah. I think that's everything I've got for now. Yeah, so my one question so far is, with the linear combiner, are they essentially representing the categories with embeddings, which is kind of what I'd expect, since they're showing, let's see, combined methods. They're taking like the features from BERT and then adding something to them. So that seems to imply it's like, well, it's got to be a vector, I would think, not just a scalar.
I think that might be pointwise or Hadamard. I'm not sure.
Okay.
A lot of these symbols change depending on
Yeah.
field and who's using them, but it looks like it might be just pointwise. It's interesting, though, that do you have a sense for looking at the different baselines? This kind of, was it called concatenation or unification? Unimodal.
Yeah.
Yeah, it's surprising that that's the best. Do you have a sense for the different data sets? If it's like, well, on this one, when Unimodal performed well, it's specifically because there weren't that many categorical features. So, you know, if the categorical features were, you know, an enormous kind of table of tabular data, then, you know, it would be kind of strange to represent a bunch of numbers in unimodal format. Do you have a sense that, like, this is just a really good place to use unimodal because the categories are themselves kind of text interpretable and there aren't that many, so you don't get an enormous vector?
Yeah. That's a good point.
I'm guessing that's the case, and you know, from what I've seen, it seems like there's no best method. It really depends on your data set. You have to do some kind of you have to kind of apply some common sense based on what your features are.
Yeah.
But yeah, that's funny. We were talking about that as kind of like a dumb, hacky solution on one of these data sets. Like,
Right.
why don't you just turn the categorical feature into text, stick it on the front of the actual text, and see what you get.
Yeah.
Funny that it performs quite well, though.
Right. Okay. I think you had a really good point there that, like, maybe Unimodal works particularly well for this data set because the categories are have meaningful textual representations. Seems like a very fancy way to say that, but yeah, they can be converted to text easily. So other features, such as I think one of the features is like the clothing ID, unique ID of the product. So I think they are feeding that in. It's probably, yeah. So that would be one where it's like there's got to be a lot of products here. Probably not enough. Yeah, I'd say 1,205, and they're binned. No. Let's see. No, that's right. Okay, yeah. So there's like 1,205 unique products in this data set, and there's 23,000 reviews. And it looks like most of the reviews are for items 780 to 1200.
Yeah.
So maybe it could learn in this context, like if you just represent the clothing item by its ID, maybe there's enough data for BERT to pull something from that. It does seem like it could be a powerful feature in the sense of like, maybe there's just some products that really suck. So everybody, like, well, no one recommends this one, but everybody loves this one.
Yeah.
So yeah, that might be, it seems like a good example of what you're talking about though, where maybe the unimodal approach is not nearly as strong for the clothing ID category as it would be for the department name, where there's a much more meaningful interpretation of the category, or textually meaningful. I don't know how else to say that.
Yeah, but like I remember some Kaggle, for example, data sets, if it's like, failures in your kind of factory equipment, there are, 50 variables that don't really have a name. And they're all numerical, so it's like looking at a giant spreadsheet, in which case, they're just like real valued numbers in this enormous kind of set of features. Or like there was one physics competition where you're looking at Large Hadron Collider, like, data, and there's just, there's like 200 sensors essentially, and they each have a different reading, but they're all just real valued inputs. So it's
right.
Totally nonsense. I would imagine totally nonsensical for like to feed into one of these BERT models.
Yeah. It does seem like this is like an assumption, but it seems like it's probably right that that BERT probably can't like make sense of values, right? Like it probably, like, especially continuous values where they're like, you've got a decimal point. Like if BERT's not gonna do math on those numbers to inform itself. So yeah, continuous values are meaningless in text form, unless you, unless like a human, you read them as numbers and treat them that way. Yeah. Okay. Yeah. Those are some really good points. So it's like the unimodal approach makes a lot of sense for categorical features that have meaningful names, but for like continuous valued stuff or real valued stuff and categories that are like, that don't have a meaningful name, seems like that they wouldn't, that strategy wouldn't work nearly as well. I wonder if like integer features are decent though. Maybe
yeah, Diogo just pointed out that you can clip your continuous data to get categorical, so you could ledger, but
yeah, that's a good point.
Yeah.
So you could bin it, right? You could like, let's see. I'll take a minute to read that. Second, you could bin the values to turn them into categorical feature. Yeah. Right. And I was thinking like maybe the product rating is a decent text feature. If you added like the reviewer gave this item 3 stars. I think BERT could do something with that. Could start. Maybe BERT can be fine-tuned to give a lot of weight to that embedding for 3. All right, let me read Yoga's comment. Tab transformers, that's interesting. TabNet, I'd like to see that. Yeah, cool, okay. Yeah, so that kind of makes me want to look at these other data sets a little more. So here, for whatever reason, the text-only approach didn't work that well. I wonder something, one detail here, like, so for Unimodal, do you simply like, convert it to a string and prepend it to the text without any other context? It sounds like maybe that's what they're proposing, but it seems to me like would it be more helpful to provide BERT with context? So instead of just saying like, 3, I think this dress is great, saying, I give this item 3 stars. I think this dress is great. So instead of just appending the number, like put it in more of a sentence, or like, this house has 2 bedrooms and 2 bathrooms.
Yeah, I wonder if in their code it's just like take the category label and then just category label : and then the value or something like that. But yeah, I agree. I think that would make it intuitively much easier for something like a BERT or a transformer-based model to pay attention to and distinguish between the different examples that this is the same feature.
Right. Yeah, toolkit authors do point out one disadvantage or one, let's see, possible problem. The token sequence length limit. So if you start adding a ton of text like this, you might start clipping the review. But I guess there's solutions for that. Yeah, okay, let's see. I keep going to that one. I wanted to look at. So Concatenate, I think, is like you've got this, let's say they take the CLS embedding from BERT, so that's 768 features. And then I think what they're doing is just adding on the rating becomes feature number 769, so they're making the vector longer, I think. That's not what I went over there to look at, though. That's right. I wanted to look at the other data sets. So they've got, right, okay. So the pricing prediction, Unimodal did not work very well, so it'd be interesting to look at that data set and maybe see if we can figure out like what went wrong there. And then pet adoption prediction. 2 text columns, 14 categorical columns, 5 numerical. Wow. Okay. Wow. Looks like, if I'm interpreting this right, it looks like this is a very hard task. Like it's very hard to predict accurately whether the pet's going to be adopted or not based on the features given. Yeah, and here the gating and the linear combiner seem to be the strongest. So maybe once I've implemented this guy, for example, applying it to this data set might be more interesting. Let's see, so I'm going to update some plans here. Investigate the Airbnb price prediction data set. Why do we think yeah, cool. Well, any other questions from anyone? Or thoughts on what we should explore or try, where we should put our energy? I am kind of curious about, maybe check out TabNet, Tab Transformers. Yeah. So Diogo, do you know if you're using XGBoost, you still have to do something with the text features, right? Is your comment about XGBoost kind of winning out? It's like, is the text being typically processed by something like BERT, or are people doing just their own kind of feature extraction on the text? Yeah, any sense of that? Okay, yeah, just right. So if it's primarily like tabular data, then yeah, transformers don't win out. Yeah. Seems to make sense. It seems like transformers are targeted towards, or attention. And is that true? I was going to say that like transformers are targeted for more like sequential data, like data where the positioning of the features matters. So that like even visual information, like the features have proximity. So, but yeah, can you use attention on categorical features and numerical features? Like, can you use attention on tabular data in a meaningful way? Does it still apply? Attention figures out how much weight to give the other features when computing the new embedding. for the current one. So yeah, seems like you could. And yeah, it sounds like tab transformers must be exactly that. Cool.
Yeah, I think TAPAS is one of their, I think it's a very recent tabular data one. I haven't looked at the paper much, but I think it's even in Hugging Face. Let's see if I can quickly see what their approach is here.
Well, it's got to be like tapas, right?
Yeah.
Yeah. Yeah.
Yeah, so some kind of combination of token embedding, position embedding, segment embedding, column embedding, row embedding, rank embedding. So I think
Oh.
so instead of just like in text, you have the sequential positional embedding. I literally just have glanced at this paper, but
Nice.
the idea makes sense. Yeah, instead of just one positional encoding vector, you have a few more that get added together, and one is, row kind of positional embedding and column. Sure, rank means in this context.
Yeah, interesting.
Oh, interesting. Yeah, rank is, so they're kind of doing their own feature extraction on it. Rank is, if column values can be parsed as floats or dates, we sort them accordingly and assign an embedding based on their numerical rank. 0 for not comparable, 1 for the smallest item, I plus 1 for an item with rank I. So they give you some kind of embedding of all of the tabular data we've seen. This one has the highest value, where this one's kind of rank on this specific column is, number 37. It's kind of an interesting idea.
I have to think about that more to understand that. Yeah, so kind of an explicit, sounds like it's like trying to give BERT some notion of math. like this value is this much higher than this other one. Does that sound right? Like if you've got 30 items or 30 values and that the value is meaningful, like the difference between 30 and 10 is meaningful.
Yeah, I would think so. I mean, I'm wondering if there's some Birdology paper where they, or if someone has tried to demonstrate a way in which BERT might understand the sequence of numbers or numerical values. Does it understand that, numbers fall in a sequence and that they are comparable and that they are ordered? Or is it just kind of, or does it just treat every number it sees as a different token ID, and it's like, well, who cares?
Right, yeah.
Yeah.
It's another word.
Yeah, exactly. So I wonder if it has a quote unquote understanding of, sequence of numbers.
Yeah. Yeah, that'd be really cool. I was talking to someone just recently about kind of a lay person about like, what can you do with BERT? and yeah, an issue we ran into is like, yeah, it probably doesn't do very well with like numerical data. So if you're trying to like do something with a text document and the numbers in it are really meaningful and important, then BERT might be weak there. I think we were talking about like what do you call that? Like annual reports from companies for stocks. So if you're like trying to trying to parse reports in order to like do some stock price prediction or something like that, then the numbers in that report are going to be super important. But to BERT, they're just words. Cool. Well, yeah, anything else? Should we wrap it up there? Yeah, I think that's a good stopping point. All right, thanks, guys. I had fun looking into this, and I'm looking forward to like playing with these data sets and some of these different techniques. I feel like I'm gonna learn a lot here, like getting to try XGBoost and doing some more PyTorch coding to make sense of some of their approaches. So should be cool. We'll let you guys know soon what next week is going to be. Nick and I are weaving in question answering and this categorical stuff. So one of us will be presenting next week. But yeah, look forward to seeing you guys there. Thanks. Have a good one.
Bye.